Okay, so last time we ended talking about a philosopher Epimenides who lived on the island of Crete and who once said that all Cretans are liars. And people talked about it as the very first, the original liar's paradox. But is it really a paradox? Let's now use your knowledge of logic and quantifiers to figure this out. So let's try. If it's a paradox, then it cannot be true and it cannot be false. But the negation of all exists. Negation of universal is existential. So if Epimenides lied, then all that it would mean is that not everybody on Crete is a liar. Doesn't say anything about Epimenides himself being a liar or not a liar. So all Cretans are liars coming from a Cretan is not really paradoxical. It just means that some people are truth teller, but not whoever said this sentence. What would make it into a paradox? Well, if he didn't talk about all the Cretans, that would have been fine, because I am lying is indeed a paradoxical sentence. If I am lying is true, well, this sentence is false, and if I am lying is false, then, well, the sentence has to be true. That's now paradoxical. So the reason I'm bringing it up is to talk more about negations. So let's go over a few more examples of negating quantified formulas and see what we get. So first of all, when we are negating a quantified formula, the only place where we apply the negation is on the actual formula under the quantifier. Why? Because the formula is something that is true or false. The formula has a value of Boolean. X's sitting under the quantifier, the elements of S, well, they can be numbers, they can be people, they can be tree. What's not a number, not a person, not a tree? Well, that kind of weird, doesn't make sense. Similarly, the set S is a set of things, and saying not set doesn't really make much sense either. If I say not trees, not X's and not trees, well, what do I mean? But if instead I say something like, not every tree in the forest is deciduous and has leaves because some trees are coniferous, like that pine tree or whatever it is in the background, then what I'm talking about is something that's true or false. Is this tree deciduous? Does it have leaves? Does it not have leaves? That I can answer. That's a Boolean. I can say yes or no, and I can say no when it's a negation of something that's true. So again, the domain, when you're negating, stays the same. Quantifiers flip. If you had a universal, it becomes existential. If you had existential, it becomes universal. And the formula under the quantifier gets a not in front of it, and then you keep going and you keep simplifying. So here is an example. Not all integers are even. Say, well, no, that's not true. Some integers are not even. So we flip the quantifier all to exist, and we put a not in front of our formula, which in this case is just one predicate, the even. Let's try a more complicated example. Some integers are both even and prime. No, none of the integers is both even and prime. Well, this corresponds to just saying for every integer, it's not that it's both even and prime. But we could simplify it further and say every integer is either not even or not prime. And this is the De Morgan's law applied to the end that you've seen many, many, many times in the previous part of the course. So usually when you negate a predicate formula, just like propositional, try to simplify it until all the negations are on the simplest units, on your predicates. Not all trees have leaves is a bit more confusing than some trees don't have leaves, or some trees have needles. And again, to reiterate, once you wrote your formula, read it and try to make sure that type checking goes through. Try to make sure that it actually reads and makes sense. If you end up with something like non-trees have non-leaves, well, maybe you need to look at your formula again and say, well, can I get rid of talking about non-trees which have non-leaves? But not all trees have leaves. Some trees do not have leaves. We're still talking about the trees. We are fine. So when simplifying negating formulas, flip quantifier and negate some formula as in propositional logic, but never change the dimension.